Okay, in this video we're going to pick up with looking at characteristics that affect volatility, and then we'll get into some different measures for bond volatility. So first, let's look at these characteristics. The most important one being maturity. So the longer the term to maturity, the greater the volatility of the bond's price in response to interest rate changes. Now it's important to note that this is everything else being equal. So if we have the same coupon rate across a variety of bonds, the one with the longest time to maturity is going to be the most sensitive to interest rate changes. It's going to be the most volatile in terms of its price changes. So the largest cash flow, the par value is getting pushed further and further out, and so this is the reason why that maturity is going to so greatly affect the volatility of the bond. That big cash flow is getting pushed out and it's being discounted more and more periods. The coupon rate is another very important characteristic that affects volatility. In this case, the lower the coupon rate, again everything else being equal, the greater the volatility of the bond's price. So with higher coupon payments, more of the bond's value is being received sooner. A higher proportion of the value is coming in those interim cash flows. In the extreme, a zero coupon bond has all of the value of the bond being received at maturity. So this would be the extreme of a very low coupon rate, zero coupon. That's going to have the greatest volatility for that particular maturity. And then finally, yield to maturity. The lower the yield to maturity, the greater the volatility of the bond's price. So that's just saying price volatility is highest when yields are low, and price volatility will be lowest when yields are high. Well, let's move on to the next slide here and look at some measures of bond price volatility. The first one being the DV01, the dollar value of a basis point change. This tells us how much in dollars the price of a bond will change for a 1 basis point, that is a 1/100th% change in interest rates. So as an example here, if the DV01 for a bond is $1.67, then if the yield to maturity for the bond goes from 5.55% to 5.56%, again that's a 1 basis point change, the price will change, and in this case it will decrease by $1.67. The rate went up by a basis point, so the price will go down by the DV01, so $1.67. Now this is going to be true for small changes in interest rates, so that is for just a few basis points, 1, 2, 5, maybe up to 10 basis points. If we start moving beyond that, we're going to get less and less accurate in terms of calculating price changes based on the DV01. So let's just go to Excel real quick and look at the calculation for a DV01. And we'll start up here at the top and look at some bonds. The base price, we're going to assume an initial yield of 7.5%. So I've got the characteristics of a bond here. For instance, bond 1 is a 5-year bond with an 8% coupon. If the yield is 7.5%, I can look at this formula. The inputs here, the rate, the coupon rate for, sorry, not the coupon rate, the discount rate for the bond. The required rate of return is 7.5%, and we're going to divide that by 2 to get a periodic rate. The number of periods I'm linking up there to the maturity. So 5 times 2 periods, C9 is the payment. So I take 8%. I'm going to multiply that times 1,000. That's the face value of the bond to get the coupon payment. Oh, lastly, I do need to divide by 2 to get the periodic payment. So that expression right there is going to return 40. And then finally, the very last argument in this function is the future value of the bond, so $1,000. And so when I stick all that stuff in, I get the initial price of this bond at $1,020, and I'm using the same formula across these 4 different bonds. Now, in this row, I'm increasing the required rate of return by 1 basis point. I've hard-coded in the 7.51%. Again, I'm going to divide everything by 2 where it's appropriate, and I get a price change. I get in this case a price decrease because the yield to maturity is going up by a basis point. And so this next line here, the DV01, is just going to be the difference between the price before the rate change and the price after. Again, it's a 1 basis point change, so this difference in price is going to be the DV01. That's how we would calculate it. So I've got a 42-cent DV01 for bond 1, $1.17 for bond 2, 33 cents for bond 3, and 38 cents for bond 4. Sometimes you'll see, and in Bloomberg, in fact, you'll see for bonds, you'll see the DV01 for $1 million position in bonds. $1 million in face value, and so this is just going to be the DV01 times 1,000, because a regular bond has $1,000 face value. If you have 1,000 of those bonds, you've got $1 million par value position. So 1 basis point change would change your value of bonds by $415 in this case, etc., as we look across the columns there. So that's for a 1 basis point change. The point I was making just a few minutes ago, that's accurate for small changes. If we looked at a bigger change, such as a 45 basis point change, here I'm doing the actual change in price. So if I look at the 1,020.53, we calculated that a few minutes ago. Now if I increase the required rate of return on this bond to 7.95%, looking in the formula there, my price goes down to $1,002. My price change is $1,850. If I was just going based off of the DV01s, I would calculate a price change of $1,871. So we're close, but we're not where we ought to be. And you can see the divergence across these other bonds is kind of getting big. This one is about a couple of bucks. So for small changes, it's very accurate. As we get bigger and bigger changes in the basis points from that initial yield to maturity, we're going to have less and less accurate estimations of the price. So that is the DV01. Let's go to the next slide and see the next measure. This is going to be duration. So we've got something called Macaulay duration. It's another risk measure that reports the, again, approximate percentage change in price for a given change in interest rates. That is the yield to maturity or the required rate of return for a bond. Again, all these things are synonymous. So this is similar in terms of calculation to a weighted average term to maturity. That's not really a good interpretation of things, but that's the way you'd calculate the Macaulay duration. When we're doing the calculations, the weights are the present value of the cash flows, that is the coupon payments or the principal repayment. We're going to take the present value of those cash flows, and then we'll divide it by the price of a bond to get the weights. So this is probably best seen in an example here in Excel. So let's go down to this portion of the spreadsheet and calculate Macaulay duration for a 6-year bond that has an 8% coupon and a 7.5% yield to maturity. So the first thing I'm going to do is line out all the periods 1 through 12, because we got a 6-year bond that's paying twice a year. We'll have 12 periods. The cash flows for the first 11 periods are going to be $40 coupon payments, so half of the $80 annual payment. Because it's an 8% coupon, we'll have $80 in cash over the course of the year. We divide that by 2, and we got $40 per period until that very last period, the 12th period, where we also collect the par value at maturity. So the cash flow there is $1,040. Next, I'm going to figure out the present value of each of those cash flows. So I'm going to discount it by the discount rate. In this case, it's going to be half of that yield to maturity rate. That's the periodic rate. The 6-month rate would be half of the yield to maturity. Of course, the yield to maturity is measured for a whole year. So 1.0375, and I'm going to raise that to the number of periods that I'm discounting the cash flow. And you can see in this case I'm referring over to that cell, the period column, and that tells Excel how many periods I'm going to discount the cash flow. So if I go all the way down here to this last cash flow and look at it, I am going to be discounting this cash flow 12 periods. So I've got the appropriate present value for each of those cash flows. If I add up all of the present value of the cash flows, by definition I get the value of the bond, the price of the bond. So you can see here it's the sum of all those cash flows. Right here I've calculated the price of the bond using the PV function, and indeed I do get the very same price, the very same value for the bond as I just did here, kind of in a longhand fashion. So back to calculating Macaulay duration, what I'm going to do is multiply the present value of each period times the value for the period. So look, I'm multiplying these two columns, these two items here, the present value of the cash flow times the period, the applicable period. And I'm going to do that all the way down and add up all of these products. So I get this measure 10,024. That doesn't really mean anything yet. What I need to do to get the duration is divide that number by the price. So I would get 9.791, and that would be measured in periods, but we really want to be talking about duration in terms of years, so I need to divide that answer by 2, and so we would have a duration measure of 4.90 years. I'll leave it to you to figure out how to use the duration function in Excel. I get the exact same answer. In fact, if I go to this and go out a few decimal places, you can see that these are exactly the same number, the same result. And so that's what the duration function in Excel is doing. It's returning us the Macaulay duration. The last thing I want to talk about in this video is getting the modified duration. Here we would just take the computed Macaulay duration and divide that by 1 plus the periodic rate, the periodic yield. So in this case it's going to be 3.75%. That's going to be half of the yield to maturity. That's going to be the per period yield to maturity. So I've got the Macaulay duration and the modified duration. In the next video we'll pick up with how do we use that measure. What does it mean and how can we use it? So I'll see you then.